Hello, I'm Tahura Moravati. I hold master's degree in electrical engineering from the University of Tehran, and I've been TA for courses like machine learning, deep learning, and I also teach English. So teaching is something that I am generally interested in. So now let's delve into the subjects and talk about what we are going to cover today, which is autograd. And I want to start by going and having a little bit low level understanding of this topic. So if we want to talk a little bit low level and from the low level perspective, I can say that you probably know that we have something like something called loss function. And the loss function, let me check out if yes, we're being recorded. So the loss function is a function that helps us to know how accurate our model is predicting, how accurate the result of our model is respected to the reality, respected to the real thing that we are trying to uh, predict. So, and to improve the model, we try generally to minimize the loss. And to do that, we need to compute the gradient of the loss with respect to the model parameters. What are the model parameters? We will talk about them later. But just generally, we know that we have something like loss function, and we try to minimize that in order to improve our model's performance. And what is AutoGrad here? AutoGrad is the tools that helps us to do that. It is the tool that helps us to calculate this gradient layer by layer in the neural network. And what makes it powerful is that it dynamically builds a computational graph to perform these gradients in each layer of neural network. So, this was a general idea of the AutoGrad, and let's go and a little bit try to implement it in order to have a deeper and more comprehensive idea of this model. So let me share my screen here. Um, okay. So you're probably able to see my background, my screen. And I wanted to start by coding exercise, building a computational graph. As I said, that AutoGraph helps us to build this computational graph. And we have a picture here that I need to explain it, and I need to explain that what this diagram work generally and how do we get an understanding of this diagram. This is the way that it works is like this. You work at this part. I must have something like this. And this is my pencil. Okay, if I want to start by here, it's like you go doing this operation. It means that x is multiplied by w, and then here you have the result, which is x multiplied by, I cannot write and type at the same time, but this is like this. So x multiplied by w. Okay, so here you have this. And then you go here. It means that you add this result to this b. So let's go to this part. And if I want to write it, as I said, it would be like w multiplied by x, and then you plus this b, which is bias. We're going to talk about this later. And this, you put this in the thon. Sorry, you put this in the thon, and you go on, which is by subtracting it to y, and then you powered this whole thing to 2. Okay, so what is this? This is the loss function. Okay, this is our definition of loss function here. And in the following part of code, I don't know how to delete this, but in the following part of the code, we are trying to explain about this code, and we are trying to implement the autograd. Okay, so here we have a class which has an input and output, and we are defining this input here. And if I want to very briefly explain about this part, is that assert is instance W and B, which shows us that W and B are our parameters. W no 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 sorry, W indicates the weights of our model, and the B indicates the bias of our model. And what is this part? What does this part mean? Simply, if I want to put it in a simple way, is that, okay, I have a condition with this input. If this condition, okay, so then you're all right, go ahead. If it's not, then stop the program and raise an error, which is assertion of error. Okay, and this is about the init part of the function, which is the part that we are trying to initialize our function with the parameters that we need. And so far we understood that we have W and B, and these are the parameters of our model. So let's erase them all and go forward. We have a method forward here, which we define the forward pass of the autograd, or the class that we are trying to generally implement. And again, we are using assert is instance, which, if I want to practice it again with you, is like we have an input X, which is a PyTorch tensor. What is tensor? Tensor is a something, it's just like NumPy. It's an array, just like NumPy array, but more powerful, particularly in deep learning applications. So, and here you need to write the model based on the explanation that we had about the loss function, and based on the explanation that we have here. We have in the comments below, we have forward pass, argument, what you should have as an input and what you should have as an output. What do you expect in return? So I guess my 5 minutes is up. And I hope you enjoyed this. Let me know if you like it or not.